Good day, learners. Welcome to Mathematics lesson. My name is Nonkululeko Kombuyisa. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. In today's lesson, we will be looking at trigonometry, the reduction formulae. Before we can go ahead with the lesson, at the end of this lesson, you should be able to derive and use the reduction formulae to simplify the following expressions. Sine into 90 plus or minus theta, cos into 90 plus or minus theta, sine into 180 degrees plus or minus theta, cos into 180 degrees plus or minus theta, and tan into 180 degrees plus or minus theta. Sine into 360 plus or minus theta, cos into 360 degrees plus or minus theta, tan into 360 degrees plus or minus theta. And you should be able to derive the negative angles, which is sine into negative theta, cos into negative theta, and also tan into negative theta. Reduction formulae are used to reduce a trigonometric ratio of any angle to the trigonometric ratio of an acute angle. So for instance, if you are given something like sine into 120 degrees, this angle is bigger than 90 degrees. So we say it's an obtuse angle. So if we want to reduce this angle to something which is less than 90, which is an acute angle, we use what we call the reduction formulae. The formulae you will use are 180 plus or minus theta, 360 degrees plus or minus theta, 90 degrees plus or minus theta, and the negative angle. Function values of 180 degrees plus or minus theta and 360 degrees minus theta. Okay, let's look into those two. Consider the following table. So suppose you are given such a table, and all the angles that are in the first table, these are the angles that are less than 90 degrees, and we say these are acute angle. So these are all the angles that are in quadrant 1. Let's do that Cartesian plane. Remember in grade 10 we said here you've got 0 degrees, you've got 90 degrees, you've got 180 degrees, you've got 270 degrees, and you've got 360 degrees. So the angles that we are talking about that are in the first column, these are the angles that are between 0 and 90 degrees. And the angles that are in the second column, we are talking about the angles that are between 90 and 180. And the angles that are in the third column, these are the angles that are in the third quadrant, which is from 180 to 270. And again, the angles that are from here to here, they are in the fourth quadrant. So before we can move along and look at that table, you need to remember the cast diagram. In grade 10, you were taught of the cast diagram, whereby we are saying all the trig ratios in the first quadrant, they are all positive. And in the fourth quadrant, only cos is positive. And in the second quadrant, only sine is positive. And in the third quadrant, only tan is positive, and the rest of them, they're negative. Okay, so let's look at the first column. Substitute sine 30 into your calculator, you will get 0.5. And if you substitute 180 minus 30 in your calculator, you'll get sine of 150 degrees. If you punch sine 150 degrees into your calculator, you will still get 0.5, which is the same as 0.5 that you get when you say sine of 30 degrees. Again, when you say sine of 180 degrees plus 30, 180 plus 30 is going to give you 210, and if you punch sine of 210 degrees, you will get negative 0.5. And if you move to the other side, in the fourth quadrant, you say sine into 360 degrees minus 30, you will get sine of 330 degrees. And if you punch all of this in your calculator, you'll get negative 0.5 degrees. So it means if you've got sine of 180 minus 30 degrees, which is in the second quadrant, you can just write it as sine of 30 degrees. You just take that acute angle as it is, because sine 30 degrees and sine of 180 degrees minus 30, it's still the same as the sine of 30 degrees. And with this one, 180 degrees plus 30, we said it's in the third quadrant. Remember, sine in the third quadrant, it's negative, right? And then 360 degrees minus 30, it's in the fourth quadrant, and your sine in your fourth quadrant is going to be negative. So hence your answer is going to be negative 0.5 and also negative 0.5. Okay, again, let's look at the second example of cos of 40 degrees, which is in the first quadrant. If you punch it in a calculator, you'll get 0.5, and cos into 180 degrees minus 40 degrees, it is going to give you 140, because 180 minus 40 is going to give you 140. If you punch it in a calculator, you will get negative 0.8. Remember, 180 minus an angle is going to be in this quadrant, of which is quadrant 2, and hence your answer is going to be negative, because cos in the second quadrant, it's going to be negative, as only sine is positive in the second quadrant. We move to the third column. You've got cos of 180 plus 40. 180 plus 40 degrees, you get 220. So if you punch cos of 220 in your calculator, you'll get negative 0.8, which is negative. Remember, 180 degrees plus an angle, it's in quadrant 4. So it means your cos in quadrant 4 is negative. Remember, in quadrant 4, only tan is positive. Hence, the answer of cos 220 is going to be a negative answer. We move to cos of 360 degrees minus 40. If you say 360 minus 40, you'll get 320. So if you punch it in your calculator, you'll get positive 0.8. 360 minus an angle, it's in quadrant 4. And in quadrant 4, only cos is positive. Hence, the answer is going to be positive. Okay? So whenever you have 180 degrees minus 40, you just take this angle as it is, but you must change the sign, because 180 minus an angle, it's in the second quadrant, and in the second quadrant, cos is a negative. So you are going to have negative cos of that acute angle. So again, 180 plus 40 degrees, it's in the third quadrant, and in the third quadrant, your cos is negative, so you will get a negative cos of this acute angle. And if you've got 360 degrees minus 40, then you can say it's cos of that acute angle. So whenever you are given an angle to reduce, you need to always say, okay, for instance, let's look at 105. 105 is in which quadrant? It's in quadrant 2. And in quadrant 2, you've got 180 degrees minus an angle, right? Okay, then you should ask yourself, tan in the second quadrant, is it positive or negative? And if it's negative, you are going to say it's negative, right? And then you get an angle that you need to subtract from 180. That will still result in 105 degrees. As a result, you get negative tan of 75 degrees. Again, if you move to 180 plus an angle, it's in quadrant 3. And in quadrant 3, your tan is positive. So you are going to say, okay, 180 degrees plus 75 degrees, it gives you 255 degrees. And 205 degrees, it's in the third quadrant. So if you punch it in a calculator, you'll get 3.7. So if you reduce this as to 180 plus 75 degrees, it's equals to tan of 75 degrees. You just take this acute angle as it is, and the sign of tan is going to be positive, because tan in the third quadrant is going to be positive. Okay, so if you move to 360 degrees minus 75 degrees, you'll get 285 degrees. And if you punch it in your calculator, you'll get negative 3.7. Remember, 285, it's above 270. So if it's above 270, it means that your angle, it's in the fourth quadrant, and in the fourth quadrant only cos is positive, meaning that tan is negative. Hence you'll get your negative tan of 75 degrees. So what does this tell you? All the angles of column 1 are angles that terminate in quadrant 1. So all these angles that are in this column, the first column, they are angles that are in the first column, which is between 90 degrees and 0 degrees. And all the angles of column 2 are angles that terminate in quadrant 2. So the angles that are in the second column, they are the angles that terminate in this quadrant, which is quadrant number 2. All the angles of column 3 are angles that terminate in quadrant 3. So all the angles that are in column 3 are all the angles that terminate in quadrant 3, okay? And all the angles of column 4 are angles that terminate in quadrant 4. So if you are looking at your answers, you'll see that sine in quadrant 4 is negative, cos in quadrant 4 is positive, tan in quadrant 4 is negative, and sine in quadrant 4 is negative. And when you are looking at the third quadrant, which is this one whereby only tan is positive, by looking at the answers, you'll see that sine is negative, cos is negative, and tan is positive, and then sine is going to be negative as only tan is positive. You move to the second column. In the second column, we are looking at the second quadrant. So in the second quadrant, sine is positive, cos is negative, and tan is negative, and also sine is a positive. And then if you move to the first column, in the first column, all your answers, they are going to be correct. They are going to be positive, as all of your trig ratios, they are going to be positive in the first quadrant. Okay, so what does this tell you? It tells you that whenever you are trying to reduce your trig ratio, you need to always say, if your angle is in this quadrant, you need to say, okay, it's just theta, or you can say it's from here going to this side is going to be 90 degrees minus your theta. Then if your angle is in the second quadrant, then in the second quadrant you will have 180 degrees minus that particular acute angle, ne? And then if your angle is in the third quadrant, then you are going to say 180 degrees plus that acute angle. And if your angle is in the fourth quadrant, then it means you will say 360 degrees minus that particular acute angle. Okay, let's move along. Let's look at functions values of 180 degrees minus theta. Okay, so if you've got 180 degrees minus theta, which is in the same second quadrant, what happens to your cofunctions? Are they your trig functions? Are they going to be positive? Are they going to be negative? Okay, so in the diagram alongside, OR is equals to OR, which is reflected. So you've got this length, which is the length of OR, and you are given your values, your coordinates as X is to Y. And then this point is reflected about the line of the y-axis. So if you take this point and you reflect it to this side, the same point, you just write it on the other side, the value of x, it changes to be negative. It was positive, so now it's going to change to be negative. And also this is your R and this is your R, which is your hypotenuse side. So if you were to do a right angled triangle, your value of y the side is going to be positive, and your value of y the side is still going to be positive because it's still above the x-axis. Okay, so let's say, for instance, they say we must find, so you've got this angle. Now this angle is going to be this side. So from here going to this side is going to give you 180 degrees. So if I were to find the whole, this small angle, I'll say it's 180 degrees minus your theta. So sine of 180 degrees minus a theta, you say it's equals to, if I'm looking at this right angled triangle, remember we are looking at this angle, from your SOHCAHTOA, still remember SOHCAHTOA from grade 10. SOHCAHTOA, it says this is opposite and this is hypotenuse, right? And this is adjacent and this is hypotenuse. And then tan, it's opposite all over adjacent. So if I were to find the value of sine into 180 degrees minus theta, I'll say the angle which is opposite to this angle, the side which is opposite to this angle, it's going to be this angle which is, sorry, that side which is y. You say it's all over. The side which is an hypotenuse side is going to be r, right? Okay, so your y is positive and your r is positive. So we say your sine is going to be positive as they did here. Okay, and then you say sine of 180 degrees minus theta. We're still looking at the same angle, which is 180 minus theta. I'm doing the same thing. I'm sorry for that. So now let's look at cos, since we are done with the sine. We say it's equals to, remember your cos, it's adjacent all over the hypotenuse side. So if I'm looking at this angle, the side which is opposite to this angle is going to be negative x all over. The value of the hypotenuse side is going to be r. So if I'm looking at my answer, it's going to be negative. So it means my cos, when 180, when cos is 180 minus theta, I'll get the cos of negative cos theta. Okay, and then let's look at tan 180 degrees minus theta, right? So if I'm looking at tan, remember we said tan, it's opposite over adjacent. So if I'm looking at this angle, I'll say, okay, the side which is opposite is going to be your y, and the side which is adjacent is going to be negative x. So it means that my tan in the second quadrant is going to be negative tan theta. So whenever you see sine of 180 degrees minus theta, you substitute it with sine theta. Whenever you see cos of 180 degrees minus theta, you substitute it with negative cos theta. Whenever you see tan 180 degrees minus theta, you substitute it as negative tan theta. Okay, let's move along. Now let's look at the function values of 180 degrees plus theta. So now you've got this. You still have your side which is OP, the side of OP. It's given as, OR, which is given as x is to y. So if I reflect this thing by this line, then it's going to be this side which is negative x. The value of x, the side, it changes to be negative, and the value of y, it's going to change to be negative y. Okay, so if I've got sine into 180 degrees plus theta, 180 plus theta, remember 180 plus theta is now in this quadrant, which is quadrant 3, right? We say it's equals to, from your SOHCAHTOA, you are going to say, but now we are looking at this angle. We are going to say sine, it's given as opposite over hypotenuse. So it means you'll get negative y all over r. So it means in the third quadrant, sine is going to be negative theta. And then let's say you've got cos into 180 degrees plus theta, it's equals to, so since I'm still looking at this angle, I say adjacent, which is negative x all over r, which is your hypotenuse side, it's equals to negative cos theta. So it means your cos in the third quadrant is going to be negative. And then if we are moving to your tan into 180 degrees plus theta, you'll say, okay, the opposite side, it's negative y, and the adjacent side, it's negative x. So if I'm checking here, negative divided by negative, it gives you a positive, right? So it means your answer will be given as positive tan theta. So only tan is positive in the third quadrant. So whenever you see your sine of 180 degrees plus theta, you'll substitute it with negative sine theta. And whenever you see 180 degrees plus theta, you'll substitute it with negative cos theta. And whenever you've got 180 degrees plus theta, and you'll substitute it with tan theta. Okay? Let's move along and look at the function values of 360 degrees minus theta. So in the diagram alongside OR, it's equals to the reflection, which is OR. So you've got OR. Then if you reflect OR by this line, which is the x-axis, it's going to be reflected to be this side. So whatever coordinates that you had, which was x is to y, the value of x is still gonna be the same because we're still looking at the same x-axis, so it's still gonna be x. But the value of y, because now we are looking at this side, the value of y this side is going to be negative y, right? Okay. So then by a reflection about the x-axis, R has the coordinates x is to negative y, what I just said, and then OR is the terminal arm of 360 minus theta. So remember, from here, we are moving it to all the way to this side. So this angle is now reflected to this side. From here up until here, 360. So if I want to find this smaller angle, I'll say it's 360 degrees minus your theta, right? Okay, so you say sine of 360 degrees minus theta. You check we are now talking about quadrant 4. I said to you, according to cast diagram, your sine in quadrant 4 is negative and only cos is positive. Let's see if that is truly true. Okay, so I've got sine into 360 degrees minus theta. Okay, so now we are looking at this angle, right? So we said sine, it's opposite all over hypotenuse. So the side which is going to be opposite here, it's going to be your negative y all over. Your r, it's going to be given as just r. Then since there's a negative here, it means your sine is going to be negative sine theta in quadrant 4. And if you've got cos into 360 degrees minus theta, that's going to be in the fourth quadrant again. And in the fourth quadrant, cos 360 minus theta, if I'm looking at this angle and I'm looking at this triangle again, you'll say the side which is adjacent to this side is going to be positive x all over. Your hypotenuse side, it doesn't change the sign, it remains as positive r. So you'll get that your cos is positive in the fourth quadrant. So you get it as positive cos theta. So if we are looking at 10 into 360, if we are looking at 10 into 360 degrees minus theta, okay, so we'll get that the side which is opposite, it's still negative y, and then the adjacent side, it's going to be positive x. So since there's a negative, it means your tan in the fourth quadrant, it's going to be negative 10 theta. Okay, so your sine into 360 minus theta, it's going to be negative sine theta. Whenever you see cos 360 minus theta, you substitute it as cos theta. And whenever you get tan into 360 minus theta, you substitute it as negative 10 theta. Okay? So let's look at these examples that we are given on the board. Okay? Before we can move along, let me just do a little bit of summary. So before we can move along, you must know that in your Cartesian plane, from what we were doing, before you get into an exam, you should be knowing that all your angles that are below, you've got 90 degrees, 180, you've got 270, and then you've got 360. So all your angles that are between 90 degrees and 0 degrees, we say they're just an acute angle, right? And then in the second quadrant, you will get 180 degrees minus theta. And then in the third quadrant, you will get 180 degrees plus theta. And then in the fourth quadrant, you will get 360 degrees minus theta. And I said to you, we've got what we call a cast diagram, whereby this is C, this is A, and this is S, and this is T. Remember, this means that only cos is positive in this quadrant. And then in this quadrant, all of them, they are positive. And then in this quadrant, only sine is positive. And then in this quadrant, only 10 is going to be positive. So before you can even try and solve your reduction formulas, you must have this in mind. Okay, let's look at example number 1. You are given 3 cos into 180 degrees plus theta, sine into 360 degrees minus theta, all over sine into 360 degrees plus theta, and then you are given cos into 180 degrees minus theta. So before you can move along with answering the question that you must always ask yourself before you start with solving reduction formulas is, your trig ratio is in which quadrant? Right? So you must check, is it in quadrant 1, quadrant 2, quadrant 3, or quadrant 4? And after getting that, you ask yourself, whatever trig ratio that you're talking about, in that particular quadrant, is it positive or negative? No? Okay, so let's look at example number 1. You are given 3. So I'm going to ask myself, cos 180 degrees plus theta, it's in which quadrant? We said it's going to be in quadrant 3, right? We said this is in the third quadrant. And in the third quadrant, cos is going to be positive or negative. We said in the third quadrant, only 10 is positive. So it means the cos is going to be negative. Then you write it as negative cos of theta. Remember, we take this acute angle. Ne? And then we look at the second one. So we are done with this one. We look at the second one. 360 degrees minus theta, it's in which quadrant? It's going to be in the fourth quadrant, right? And sine in the fourth quadrant, is it going to be positive or negative? We said it's going to be negative because only cos is positive in the fourth quadrant. So it means you'll open a bracket and then you say it's negative sine theta. And then it's going to be all over 360 degrees plus theta. It's going to be in the first quadrant because look here, from 360 minus theta, these are the angles that are between 0 and these are angles that are between 270 and 0 degrees. So if I move from 360 to this one, any number that is above 360 degrees, you'll say it's in the second quadrant. It's in the first quadrant. I'm sorry about that. So 360 degrees plus theta, it's going to be in the first quadrant. So we say in the first quadrant, all of the trig ratios, they are going to be positive. So you'll get positive sine theta. Then 180 degrees minus theta, it's going to be in the second quadrant. And cos in the second quadrant, is it going to be positive or negative? It's going to be negative, right? So it's going to be negative cos theta because only sine is positive in the second quadrant. So from there, we need to multiply out our signs. So I say negative times negative, I'll get positive. Okay, you don't have to write the positive. Negative times negative, you get positive 3 cos theta and sine theta. It's all over sine theta times negative cos theta, you get negative sine theta times cos theta. So your sine theta and your sine theta, then you've got your cos theta and your cos theta, then your answer is going to be, therefore, your answer is going to be negative 3. Okay? So we said this one, it's in the second quadrant, right? And we said this one, it's going to be in the first quadrant. Okay, let's move to the second one. Then we are done with simplifying there. Let's move to the second one. You've got 180 degrees plus theta. We said 180 degrees plus theta, it's in the third quadrant, né? And in the third quadrant, cos is going to be negative. So you'll get negative cos theta. And then you've got 180 minus theta. We said it's in the second. Let me write it nicely. 180 minus theta, it's in the second quadrant. So in the second quadrant, obviously, we said tan is going to be negative. So you say it's tan theta. And then 180 degrees plus theta, we said again, it's in the third quadrant. And in the third quadrant, a sine is going to be negative sine theta. All over 180 degrees minus theta, we said it's going to be in the second quadrant. And in the second quadrant, sine is going to be positive. So you get sine theta, and you're still left with this sine theta. So since there is no reduction formula there, I just bring it back as it is. Okay, so let's do the multiplication. So I say negative times negative, I'll get positive cos theta times the tan theta. You can change it. Remember from your identities, we said tan theta. If you change it, you'll get sine theta all over cos theta, right? So if I change it, I'll get sine theta all over cos theta. This one is all over 1. And then I still have my negative sine theta. And then I say it's all over sine theta times sine theta. I'll get a sine squared theta. Okay, from here, this one is also all over 1. So if I multiply everything out, the cos theta will go out with the cos theta. The negative sine theta will go out with one sine theta. Then I will be left with let me use a different color. So I will be left with negative sine theta all over 1 sine theta, since I took out 1 sine theta. So sine theta and sine theta, again, it cancels each other out. Then I'm left with negative 1. That's my final answer, and I'm done simplifying. Okay, let's move to example number 3. Example number 3, you are given 1 minus a sine squared into 180 degrees plus theta all over 1 minus cos into 180 degrees plus theta. Okay, so first things first, this one, it's 1 over 1 minus 180 degrees plus theta. It's in the third quadrant. So it means that in the third quadrant, sine is going to be negative. So it means you will have negative sine theta. Then you close the brackets. You still have the squared. So you put the squared outside, right? And then it's all over 1 minus the 180 plus theta. We said it's in the third quadrant. So cos in the third quadrant is going to be negative. So you'll still get negative cos theta. Okay, and then from there, let's simplify. So you have 1 all over 1 minus all of this. Remember the negative, if it's squared with an even number, then you'll get positive sine theta squared all over 1 plus, because negative times negative, it gives you positive, 1 plus cos theta, right? Okay, so from there, you're just gonna do the scissor method. So you'll multiply this side, you multiply this side, and you multiply this side. So if you are subtracting 2 fractions, you need to use your scissor method. So you say 1, that 1 multiplies the 1 plus cos theta. Then you've got minus 1, the 1 also minus the sine squared theta. It's all over 1, which multiplies 1 plus cos theta, right? Okay, and then from there you'll say 1 times the 1, you'll get 1. 1 times the cos theta, you'll get plus cos theta, minus 1 times the sine squared theta, you'll get the sine squared theta. and then it's all over 1. If you multiply 1 by everything inside the bracket, you'll just get 1 plus cos theta, right? And then from here, I'm checking what is it that I can do in my numerator so that it can cancel my denominator. Obviously, you need to find a way to change this thing to be all in terms of cos. So remember, from your identities, we said this identity, we've got an identity which is equals to 1. So if I say sine squared theta plus cos squared theta, I'll get 1. So if I add the sine squared theta plus the cos squared theta, it gives me a 1. And if I want to find a sine squared theta, I can take this cos squared theta and transpose it to the other side, right? So it means I'll get sine squared theta, you say it's equals to 1 minus the cos squared theta. So whenever you see your sine squared theta, you can substitute it with 1 minus cos squared theta. So you'll say it's 1 plus cos theta minus, inside the bracket, you substitute 1 minus cos squared theta. Then you close the bracket. It's all over 1 plus cos theta. And then from here, we just multiply out our bracket. So you will get 1 plus cos theta, the negative times the positive, and the negative times the negative. You will get negative 1 plus cos squared theta. You say it's all over 1 plus cos theta. Okay, so the 1 and negative 1, those are the additive inverses. So 1 minus 1, it's going to give you a 0. And then from there, I can see that I've got cos theta and cos squared theta. There is something common. And what is common is cos theta. So I can take out cos theta as a common factor, right? And if I take out cos theta as a common factor, I'll be left with 1 plus. If I take out 1 cos theta, I'll be left with 1 cos theta, right? So it's all over 1 plus cos theta. So since this is a multiplication, now I'm allowed to say this divided by that, and then my answer is given as cos theta. Okay, so now we are done simplifying. So if you simplify that sum, you get cos theta. Let's move along. Okay, so in summary, if theta is an acute angle, the terminal arm of 180 degrees minus theta will lie in the second quadrant. I've already said that in the previous slide. And then 180 degrees plus theta will lie in the third quadrant. Already I've said that. Moving to 360 degrees minus theta, it is going to lie in the fourth quadrant. Ne? Okay, let's look at the function values with 90 degrees minus theta. 90 degrees minus theta. So your 90 degrees minus theta and your 90 degrees plus theta, we call them your cofunction. Why are we calling them your cofunction? Because if you are given something with, if you are given sine into 180 degrees minus theta, it changes the cofunction to cos of theta. So if it's sine, it changes to cos. And if it's cos of 90 degrees minus theta, it is going to change to be sine degrees. So if it's cos, it changes to sine degrees. So how does this happen? Okay, let's look in the diagram alongside. So in that diagram, again, we're still looking at the length of OR. So if we reflect OR about the line of Y, it's equals to X. So if we reflect our OR about this line, then it means this coordinates, because this is an inverse, y is equals to x is an inverse. So if we reflect it about that line, then it means this coordinates is going to change. It's going to change, and your value of x is now going to be y, and your value of y is now going to be x, as shown in the diagram. Okay, so your sine into 90 degrees minus theta. So if I'm looking at this angle, remember we said our x is now y, and then our y is now x, and then our r is still giving is still given as the r. So if I'm looking at sine of 90 degrees minus theta, remember, if I'm looking at this angle, then it's going to be my opposite side. It's going to be here it's given, it's going to be x all over r. It's equals to x over r, and it's positive. X over r, you know that it's adjacent all over hypotenuse, and adjacent all over hypotenuse, it's given as your cos theta. So whenever you've got sine of 90 minus theta, you must always change it to cos of theta And then if you've got cos of 90 minus theta, which is given as y all over r, you must always change it to sine theta. So whenever you've got cos of 90 degrees minus that, you change it to sine degrees. That is going to be in the first quadrant, and obviously both of them, they're going to be positive because 90 minus theta is in the first quadrant. And remember what I said in the first slide. I said all your trig ratios in the first quadrant, they are going to be positive. All right? Okay, so function values of 90 degrees plus theta. Now we're talking about the ones that are in the second quadrant. So 90 plus theta, it's in the second quadrant, and your 90 minus theta, it's in the first quadrant. Okay, so if we reflect this OR about this line again to this side, your value of y is going to change to be negative y, and also your value of x is going to be now positive x. So if you are looking at sine into 90 degrees plus theta, you will get x all over r, and your x all over r, remember, it's an adjacent all over the hypotenuse side, and adjacent all over the hypotenuse side, we say it's equivalent to cos theta. Okay, and then cos into 90 degrees plus theta, it's given as negative y all over r, and remember y, it's an opposite side, so it's going to be negative sine theta. Okay, so it is important to note that the terminal arm of 90 degrees plus theta lies in the second quadrant if theta is an acute angle. So someone else will be asking a question as to why is 90 plus theta, cos 90 plus theta, making sine to be negative even though it's going to be in the second quadrant. So in the second quadrant, I agree it's going to be negative y all over r, right? So negative y all over r, since it's negative, then it's going to give you negative sine theta. So if you are doing it on your own and you are given cos of 90 degrees plus theta, you should first ask yourself, 90 plus theta, it's in which quadrant? And it's going to be in the second quadrant, ne? It's going to be in the second quadrant, right? And you ask yourself, in the second quadrant, cos, is it going to be positive or negative? Then it's going to be negative. So you need to determine the sign first before you can change your trig ratio. Ne? Then, obviously, since it's 90 plus theta, it's going to change to be negative sine theta. Ne? And again, here they made summary for you. Sine of 90 plus theta, it's cos theta. 90 plus theta, cos of 90 plus theta, it's given as negative sine theta. Function values of 90 plus or minus theta are the only function values that change the trigonometric function you are working with when you are simplifying. So when you are dealing with function values of 90 plus or minus theta, sine changes to cosine and cosine changes to sine. I've been explaining this. So whenever you are dealing with the cofunctions, which is 90 plus or minus theta, so if you are dealing with sine, you must change the sine to cosine. And if you are dealing with cosine, then you must change your cosine to your sine. Okay, let's look at example 2. Example 2, you are given number 1 is cos of 180 degrees plus theta times cos into 90 degrees minus theta all over sine into 90 plus theta and times sine into 180 degrees minus theta. So 180 plus theta, we said it's in the third quadrant, right? So in the third quadrant, cos, we said, is going to be negative. So you'll get negative cos of which angle? This acute angle. Okay, and then we look at 90 minus theta. I said 90 minus theta, it's in the first quadrant, right? And in the first quadrant, cos, is it positive or negative? It's going to be positive. And since we are dealing with the co-function, this one is going to change to be sine, right? So it means I'll have sine theta. It's all over 90 plus theta. We said it's in the second quadrant, and in the second quadrant, sine is positive, right? So it's going to be positive cos theta. Why is it changing to cos and not remaining as sine? Because we are dealing with 90 degrees plus theta, which is our cofunction. Remember, cofunctions, you always has to change the trig ratio. So since we are dealing with sine, we need to change it to be cos. And then 180 degrees minus theta, it's going to be in the second quadrant. And in the second quadrant, your sine is positive. And 180 degrees minus theta, it's not a cofunction. So we just leave our sine theta as it is. So your negative times positive, you'll get negative cos theta sine theta. It's all over cos theta times your sine theta. So your sine theta divides the sine theta, and then your cos theta divides the cos theta. Then your answer is just going to be negative 1. Okay, that's simple. Okay, let's move to example 2. So in example 2, you are given sine squared into 360 degrees minus theta. It's all over cos into 90 degrees plus theta times a sine into 180 degrees minus your theta, right? So 360 minus theta, it's in the fourth quadrant. So this one is going to be in the fourth quadrant. And in the fourth quadrant, sine is going to be negative, right? So you say negative sine theta. Then that squared, you still need to put it there. It's all over 90 degrees plus theta. It's in the second quadrant, and in the second quadrant, cos is negative. So it means you'll say it's negative cos, and then you can't say cos because it's a trig ratio, your trig ratio of 90 plus theta. Ne? So it's going to change to be sine since we are dealing with your cos, right? Okay, let's move to the third one. You've got 180 degrees minus theta. 180 minus theta, it's going to be in the second quadrant. And in the second quadrant, sine is going to be positive. So it means you'll have positive sine theta. Okay? And then from there, from here, you'll get the negative, it's being affected by that squared. Then your answer will be positive sine squared theta. It's all over negative sine theta times sine theta, you'll get negative sine squared theta, right? And then your sine squared theta and sine squared theta, then your answer is going to be negative 1. So when you are simplifying, that's how you simplify. Don't lose marks, because in your exam, the way they mark, they'll just give you a mark for changing this one, and they'll give you a mark for changing this one, and then they'll give you a mark for changing this one, and the mark for the answer. So even this side, for being able to change this, you'll get a mark. For being able to change this, you get a mark. For being able to change this, you get a mark. And for being able to change that, you get a mark. That's how normally they mark in your paper 2. Okay, now let's look at what we call the negative angles. So now if we're going anti-clockwise, in an anti-clockwise direction, this angle, which is theta, when it comes this side, it becomes negative theta, all right? So whenever, we're still doing the same things that we've been doing in the previous slides. So you can just go through the same slides and you see that what we've been doing. So sine of negative theta will be written as negative sine theta. So negative an angle, it's in the fourth quadrant. So if it's in the fourth quadrant, obviously your sine is going to be negative, your cos is going to be positive, and then your 10 it's going to be negative, because only cosine is positive in this quadrant. So Sine of negative an angle, it's going to be negative sine theta. Cos of negative angle, cos theta. Tan of negative theta, it's going to be negative tan theta. Okay, let's move along. Let's look at example number 3. So example number 3, you are given sine into beta minus 170 degrees. So beta minus 180, you can also write it as negative 180 plus beta. Okay, let me explain something before we move along. So with your negative angles, since you've got theta here and you've got 360 minus theta and you've got 180 plus theta and you've got 180 minus theta, then if you are going in an anti-clockwise direction, this angle is going to be negative theta in the fourth quadrant, and this one, it's going to be negative 180 degrees plus theta. Then this one, it's going to be negative 180 degrees minus your theta. Ne? So those are your negative angles. So let's look at this example. So I was still saying beta minus 180 degrees, you can also write it as negative 180 degrees plus your beta. So beta minus 180 degrees, it's a negative angle that is in which quadrant? Quadrant 3, right? So in quadrant 3, sine is going to be, so this is in the third quadrant, sine is going to be negative. So you say it's negative sine of beta, because now the angle is still this one, negative sine beta. Ne? And then you've got negative beta minus 180 degrees, you can write it as negative 180 degrees minus beta. So 180 minus beta, it's in the second quadrant. In the second quadrant, 10 is going to be negative, so it's going to be negative 10 of beta, right? Okay, and then 180 degrees plus beta, it's going to be in the third quadrant, and in the third quadrant, don't forget your cos is going to be negative, so you'll have negative cos beta. It's all over. Okay, so negative b or negative beta, it's in the fourth quadrant, and in the fourth quadrant we said that your cos is going to be positive, so it means you'll have positive cos beta. Okay, and then 360 degrees plus beta, it's going to be in the first quadrant. We have said that already, and in the first quadrant all your trig ratios are going to be positive, so it means you'll have positive sine beta. Okay, so let's multiply the signs. So you'll get negative times the negative, you'll get, it's still going to be negative because this negative will multiply this one, and then you'll be left with that one. So you're still left with sine beta, 10 beta. Let's actually change the 10 beta. Do we need to though? No, we don't need to. It's fine, let's leave it. So 10 beta, and then it's cos beta, and then it's all over cos beta times sine beta, right? So your sine beta and your sine beta, you only do this when there's multiplication. So if there's a sign in between, you cannot, mathematically it's not correct. So cos beta with that cos beta, then your answer is going to be negative. It's not going to be negative 10 beta. Then you've got yourself your answer. Okay, let's move to the other example. So the other example, we've got theta minus 180 degrees. So you'll write it as 180 degrees plus theta. 180 degrees plus theta, we said it's in the third quadrant. So in the third quadrant, cos is going to be negative. So you'll get negative cos theta. And then 90 degrees minus theta, we said is going to be in the first quadrant. And in the first quadrant, all your trig ratios are going to be positive, right? So it means you'll get positive sine theta. Why is it changing to sine theta, not remaining as cos theta? Because the 90 minus theta, we said it's a cofunction, and whenever you see the 90 minus theta and 90 plus theta, you must change sine to cos and cos to your sine. It's all over. Then your 90 plus theta is going to be in the second quadrant, and in your second quadrant your sine is positive, so it's going to be positive cos theta. You move to the other one. This one you can write it as negative 180 degrees minus theta. This is in the second quadrant because I've got 180 minus theta. It's a negative angle that is in the second quadrant, right? Okay, so in the second quadrant, sine is going to be positive, so it means I'll get positive sine theta. Okay? So the sine theta and the sine theta, the cos theta and the cos theta, and then the sine theta and the sine theta, then your answer will be negative 1. Your answer will be given as negative 1. Okay, let's move along. Numerical reductions. So let's look at the numerical reductions. So what if now you are given sine of 120? So if now there's a number here, how do you reduce that number? How do you reduce your cos of 380 degrees? How do you reduce such a number? So in numerical examples, you apply the reduction formulae to reduce a trigonometric ratio with an angle greater than 90 degrees to a ratio with an acute angle. The acute angle, called the central angle, is the angle theta that lies between the rotating arm and the x-axis. Okay, so if we are looking at the steps to follow when you are doing your numerical reductions, you need to decide on the quadrant and hence the plus or minus sign. So you need to use your cast diagram so that you can decide on the quadrant. Is it in quadrant 1, quadrant 2, quadrant 3, or quadrant 4? Then you can use your plus or your minus. You keep the function trigonometric ratio the same. Replace the angle with the central angle, acute angle between arm and the x-axis. So if you've got sine of 120 degrees, first step you must ask yourself, it's in which quadrant? So 120 degrees, it's less than 180, but also it's greater than 90 degrees. So it means it's in the second quadrant. And in the second quadrant, you'll get sine into 180 degrees minus 60 degrees. So, sorry, yes, minus 60 degrees. So if I say 180 minus 60, I get my 120 degrees. So whenever you are solving for this one, you can say for this unknown, let's say it's an unknown, you couldn't find the 60 degrees. So you'll say, okay, sharp 180 degrees minus the unknown, it equals 120 degrees. Then your negative, that is going to be 120 minus negative 180. Divide by negative, divide by negative. Then your x is going to be positive 60 degrees. So always you must write this acute angle. So if I say 180 minus 60, I'll get positive 120. Okay, so let's move. Example number 4. Write the following as the function value of an acute angle. So you are given, the first one, you are given sine of 290 degrees, right? So you need to ask yourself, 290 degrees, it's in which quadrant? So you use your Cartesian plane. In your Cartesian plane, you've got 0, 90, 180, 270, and 360, right? So 290, obviously, it's going to be above 270. So it's above 270, but it's less than the 360. So it means it's in the fourth quadrant. So in the fourth quadrant, I said you'll use your sine into 360 degrees. So if you subtract 360, if you subtract 290 from it, you'll get 70 degrees. So it means here it's going to be your 70 degrees. Then you ask yourself, since it's in the fourth quadrant, sine in the fourth quadrant, is it going to be positive or negative? And obviously it's going to be negative sine of 70 degrees. Why? Because 180 minus an angle, it's in the fourth quadrant. Okay, then let's move to the second one. The second one, you've got 10 of 197 degrees. So 197 degrees, obviously it's going to be above 180, and it's less than the 270 degrees because it's not above 270 degrees. So you ask yourself, since it's in the third quadrant, tan, is it positive or negative? It's positive. So it means you'll get tan of 180 degrees plus 17. So if I add 17, I'll get 197. So third quadrant, tan is positive. You say tan 17 degrees, then you are done. Okay, we move to the last one. The last one, you are given cos of 120 degrees. So 120 degrees, it's less than 180, but it's less than the 90 degrees, right? So it means it's in which quadrant? Second quadrant. So in the second quadrant, you'll get cos of 180 degrees minus 60 degrees, right? And then you say 180 minus 60, it's in which quadrant? Let's continue down here. It's in which quadrant? So it's in the second quadrant, and in the second quadrant only sine is positive, so you'll get negative cos into 60 degrees. But 60 degrees, it's a special angle. So special angle of 60 degrees, if you still remember your special angles from grade 10, your special angles is going to be given as negative 1 all over 2. Then you get your final answer. Okay, example number 5, numerical reductions with negative angles. So now we are looking at numerical reductions with negative angles. What do you do when you are given numerical reductions with negative angles? Okay, so I've got a negative 1, 1, 2. So first things first, you still do what I said you must do. You must ask yourself, negative and angle, it's in which quadrant? And negative and angle, it's in quadrant 4. And in quadrant 4, is sine positive or negative? So it's going to be negative sine of 1, 1, 2. 1, 1, 2 still need to be reduced because it's in the second quadrant. So you still need to say, okay, negative sine into 180 degrees minus it's minus 68. So it means you'll get negative sine of 68 degrees. Because 180 minus an angle, it's in the fourth quadrant, and sorry, it's in the second quadrant. I'm sorry about that. It's in the second quadrant, and in the second quadrant, sine is positive, right? So it's going to be negative sine of 68 degrees, the negative that it took from the negative angle, right? Okay, let's move to negative 286. 286, it's negative. So you ask yourself, negative and angle, it's in which quadrant? It's in quadrant 4, right? And in quadrant 4, is tan positive or negative? It's negative tan 286 degrees, right? And then from there, you ask yourself, 280 degrees, is it in quadrant 2, quadrant 3, quadrant 4? And obviously it's going to be in quadrant 4 because it's above your 270. So it means you'll say negative 10 into 360 minus, you say 360 minus your 286, so that you get the acute angle. So you'll get negative 74 degrees, right? Okay, and then from there you'll get a negative, you ask yourself 360 minus an angle, it's in which quadrant? It's going to be in quadrant 4, and in quadrant 4 tan is going to be negative, so it's going to be negative tan of 74 degrees, right? So negative times negative, you get a positive tan of 74 degrees. Don't forget the degrees because we are dealing with the degrees, right? Okay, we move to negative 251. So negative 251, again, you ask yourself, negative an angle, it's in which quadrant? So negative an angle, it's in quadrant 4, and in quadrant 4, cos is going to be positive, right? So it means you'll get positive of cos 251. So 251 is in quadrant 2, or is it in quadrant 4? Is it in quadrant 2, 3, or 4? So obviously if it's less than 270 and it's greater than 108, it's going to be in quadrant 3, right? So it means in quadrant 3 you'll get cos of 180 degrees plus, you say 180 plus 251, you'll get plus 71, you will get your 251. So 180 plus an angle, it's in the third quadrant, and in the third quadrant cos is going to be negative, then it's 71 degrees, right? Okay, let's move. So numerical reductions with algebraic ratios. So how do you solve numerical reductions with algebraic ratios? Steps on solving the above, you must draw the diagram. So for instance, if you are given something like cos 10 degrees, it's equals to t. So t, obviously you know that it's all over 1. And since it's a cos, then it means this is your x and this is your r. And this is going to be your angle. So you must check it's going to be in which quadrant. So since this answer is positive, then it means it's going to be in the first quadrant. In the first quadrant, your value of x, we said it's x. The value of y, we don't know it. And the value of r, it's going to be 1 because it's given here, it's r. And then your angle, it's 10 degrees. Then you find the other angle there. And then this one, it's 90 degrees because we are still talking about the right angled triangle. Then from there, you need to use your theorem of Pythagoras to find the unknown side. Ne? So you find the third side by using your Pythagoras theorem. I've explained that already. Reduce the ratios or to ratios with acute angles. Check your signs. Use the diagram to help you write down the required ratio. Okay. Let's look at the example of cos 20 degrees is equals to t. They say determine the values of the following in terms of a t. All right. So you are given cos of 160 degrees, b cos of negative 200 degrees, c sine of 250 degrees, sine of 20 degrees, and tan of 20 degrees. So let's start with cos of 160 degrees. So before we can move along, we need to sketch the diagram. Remember, the first thing to do when you are dealing with reduction formulas with algebraic ratios, then you need to draw the diagram. So you'll say, okay, I'm given cos of 20 degrees, right? And they said it's equals to t. T, it's all over 1. And since it's cos, it means this is x and this is r, right? Okay, so we need to draw the diagram. So in my diagram, since this one is positive and this one is positive, it means it's in the first quadrant. So we substitute our angle of 20 degrees, and then we've got our x as t, and then we've got our r as 1. Then we need to find our y. So how do you find your y? you will say x squared, which is your theorem of Pythagoras, plus y squared, it's equals to r squared. So your x, it's given as your t, your square, plus your y, it's given as your y, because it's an unknown, we don't know it. And then your r is given as your 1. And then you need to square, right? But what are we solving for here? We are solving for our y, the one that we don't know, right? So you'll say y squared, it's equals to 1 squared. You take the t squared to this side, then it's going to change the sign to be negative t squared, right? And then you put a square root, and you also put a square root so that you can remove the squared. So you'll get y is equals to plus or minus the square root of 1 minus t squared. So since it's plus or minus, we need to choose one answer which is suitable for this diagram. Obviously, because this is above the x-axis, it means our y is going to be a positive. So it means this side, you'll get that your y, it's given as 1 minus t squared. Okay? So now we can do what we... Okay, let's look at special angles before we can. Let me see if we answer here. If we get special angles, we'll have to go and do special angles first. So I'm looking at cos 160 degrees. So cos 160 degrees, you ask yourself, 160, it's in which quadrant? 160, it's in the second quadrant. So you'll say cos 180 degrees minus, what are we subtracting there so that we can get your 160 degrees? So you say 180 minus your 160, you are getting your 20 degrees, right? So if you are getting your 20 degrees, you ask yourself, 180 minus an angle, it's in which quadrant? Cos of 180 minus that, it's in which quadrant? It's in the second quadrant. So it means your cos is going to be negative cos of 20 degrees. And we said cos of 20 degrees is equals to t. So it means your answer will be negative t all over 1, right? And then we move to sine of 20 degrees, which is this one. So sine of 20 degrees, you go to your diagram. So if I'm looking at this angle is going to be opposite. So my opposite side, it's going to be given as 1 minus t squared all over. The hypotenuse side is still going to be given as 1, right? Okay. Let me just erase here so that I can get some space. Okay, so now we are looking at cos into negative 200. Negative and angle, we said it's in the fourth quadrant, and in the fourth quadrant, cos is going to be positive cos of 200. And 200, it's in the third quadrant, so you'll say cos into 180 degrees plus 20. You will get cos 180 degrees plus 20. It's in the third quadrant, so in the third quadrant, cos is negative. You'll get negative cos into 20 degrees, and obviously your negative cos 20 degrees, it's going to be negative t all over 1, all right? And then if we move to 20 degrees, let's do 10 and 20 degrees. So the side, which is going to be opposite, obviously, it's going to be 1 minus t squared. Then the side that's going to be adjacent is going to be your t. Then you get your full marks. And then let's do the last one. You've got 250 degrees. So your sine of 250 degrees. You ask yourself, 250 degrees is in which quadrant? So that's going to be in the quadrant 3. So you'll say sine of 180 degrees minus okay, so it's plus, sorry, no? So it's plus 70 degrees, you'll get 250 degrees. So 70 degrees, you say, okay, 180 plus theta, it's in quadrant 3. And in quadrant 3, sine is going to be negative. So you'll get negative sine of 70 degrees. And here you've got 20, here you've got 90. So here it means you are going to have the 70 because of sum of angles in a triangle. The sum of angles in a triangle, they must always sum up to 180 degrees. So negative sine into 70 degrees. If I'm looking at 70, the side which is opposite is going to be t. And then the side that's going to be in hypotenuse is going to be 1. Then you get your full marks as they are. Okay, let's move along. Let's move to numerical reductions with special angles. So you've got triangle 1, whereby you are given the square root of 2, and then your hypotenuse side is given as the square root of 2. Your opposite side to this, it's 1. And if you are looking at this one, the opposite side is still 1. And then you already know this one from grade 10. So sine 45, if I'm looking at this angle, the side which is opposite, it's 1, right? And the side which is hypotenuse, it's root 2. So sine 45, you'll always write it as 1 all over root 2. And if we rationalize, you'll get root 2 all over 2. And cos 45, it's given as 1 all over root 2. And if we rationalize, you'll get root 2 over 2. And tan 45 degrees, you'll get 1 all over 1, which is just 1. So again, if I'm looking at this triangle now, and I've got A, B, and C, this side is 2, it's 1, and here it's going to be root 3. So you must always, you must just know these triangles, because in your exam, you're not going to be given the sine of 45, the cos of 45, the tan of 45. Sometimes they'll say, without the use of a calculator, you need to find all of that. So you just need to make sure that you know your special angles by heart. So whenever you've got sine 30, you can write it as 1 over 2. If you've got cos 30, you can write it as root 3 over 2. And then if you've got tan 30 degrees, you can write it as 1 all over root 3. And then if you've got sine 60 degrees, you can write it as a root 3 all over 2. Then if you've got cos 60 degrees, you can write it as 1 all over 2. Then your tan 60 degrees, it's given as a root 3 all over 1. It's equals to, which is just a root 3. So also this diagram as well, you need to understand it, but it's still the same as the still talking about the special angles. So if you understand the triangles better, or if you understand this diagram better, it's still fine as long as we all get the same answers. So let's look at that example 7, which says, use the special angle diagrams to calculate the following. Verify your answers by using a calculator. So you've got sine 60 degrees. We said sine 60 degrees, it's here. So if I'm looking at this one, the side which is opposite is going to be root 3. And the side which is an hypotenuse side is going to be 2, right? So it means I'll get my sine of 60 degrees as root 3 all over 2, right? And then we move to, I think it's, let me check. Tan 45, we said it's just going to be 1 out of 1, which is going to be 1. And then when we are checking for our cos 0 degrees, our cos 0 degrees, obviously it's going to be the adjacent side. The adjacent side all over our hypotenuse. So your cos 90 degrees is just going to give you 0. So it's cos 90 degrees. We say it's equals to x all over r. And your x, it's going to be given as your 0. And your r is going to be given as 2. So whenever you see cos of 90 degrees, you must know that it's 0. Okay, and then this side, your sine of 270 degrees, so it's going to be y all over x, which is just going to be negative 2 all over 2, and it's going to give you negative 1. That's if you are using this diagram. So if you are using this diagram, you'll get all of those answers. Okay, and then we are done. Example 8, numerical reductions with core ratios. Simplify the expression as far as possible. So you've got tan into 210 degrees, sine 480 degrees, sine of 170 degrees, cos of 225 degrees, sine of 315 degrees, cos of 260 degrees. So let's start with this one. So 210, obviously it's going to be in quadrant 3 because it's bigger than 180 degrees, but it's less than 270. So it means you will have 10 of 180 degrees, you say plus, then in your calculator you'll press your 180 minus the 210, then you'll get a 30 degrees. So it means if you add 30 degrees, you'll get your 210 times, if you say sine into 360 degrees, 480, it's in the first quadrant. So in the first quadrant, you'll say 360 degrees, you say 480. So you'll say it's 360 degrees plus 120 degrees. Then you say it's sine 170, it's in the second quadrant, so it means you'll have 180 degrees minus 10 degrees, so that you can get the 170. It's all over. Okay, so you'll say now cos of 225, it's in the third quadrant, so you'll say it's 180 degrees plus 45 times sine of 360 degrees, because 315 it's in the fourth quadrant. So if you say 360 minus 315, you'll get 45. And then 260 degrees, it's still in the third quadrant, so your cos into you say plus 80 degrees, right? So we said 180 plus D30, it's in the third quadrant, and in the third quadrant, tan is positive. So it means you'll have tan 30 degrees, and then again, you'll have 360 degrees plus 120, which is in the first quadrant. So your sine, you'll have sine, which is positive 120 degrees. And then 180 minus 10, it's in the second quadrant, and sine is positive. So it means you'll have a sine of 10 degrees. And then it's all over 180 plus 45, it's in the third quadrant, and cos in the third quadrant, it's negative. So you'll get negative cos of 45 degrees. And then 360 degrees minus 45, it's going to be in the fourth quadrant. And in the fourth quadrant, sine is going to be negative. So you'll get negative sine 45 degrees. And then 180 degrees plus an angle, it's in quadrant 3. And in quadrant 3, cos is going to be negative. So you'll get negative cos of 80 degrees, right? Okay, so now we need to change all of this. So we said tan 30 degrees. Let's check. We said tan 30 degrees, it's going to be given as 1 all over root 3, right? So you write it as 1 all over root 3. And then we said sine of 120 degrees is going to be in the second quadrant. So it's still going to be sine into 180 minus it's 180 minus 120. It's going to be 60 degrees. And then your sine 10, it's not a special angle, so we just leave it as it is. It's all over. And then it's negative cos 45. So we said we set our cos 45, it's going to be given as 1 all over root 2 or root 2 over 2. Ne? Okay, it's negative, sorry. And then we've got negative sine 45, so also it's going to be negative root 2 all over 2. And then we've got negative cos 80, so you'll get negative cos 80 degrees, and you just leave it as it is. And then from there, we're still not done. Yeah, it's gonna take a lot of space. Let me see if I've got a space this side. No, I don't have space. So we'll need to erase this upper part, if you'll allow me. I'll only erase this part that is on top. I hope you have copied everything that I've written on top. Okay, so we're going this side now. Okay, so 180 minus 60, it's in the second quadrant, and in the second quadrant, sign is going to be positive, right? So it means you'll have 1 all over root 3, and then you've got sine of 60 degrees. It's positive because in the second quadrant it's positive. And then you've got sine 10 degrees all over root 2 times root 2, I'll get positive 2, and 2 times 2, I'll get a 4, right? And then it's still going to be negative because you've got this negative. And then you've got cos of 80 degrees. Okay, so let's change our sine of 60 degrees again. So we said sine of 60 degrees is going to be root 3 all over 2, right? So let's go back. So we say it's 1 all over root 3. And then it's root 3 all over 2. And then it's sine of 10 degrees. It's all over 2 all over 4, right? Okay. So if I say 1 times root 3, I'll get root 3. Root 3 times 2, I'll get 2 root 3, right? And then the root 3, this root 3 and this root 3, we cancel each other out. So I'll be left with 1 all over 2 into sine of 10 degrees all over 2 all over 4, which is going to be, oh sorry, here I forgot to put the cos 80 degrees. Remember, it's still there. So 2 all over 4, it's 1 all over 2. And then I've got cos of 80 degrees. So I need to do something with, let me just put it back. I need to do something with this sine 10 degrees and cos 90 degrees. It's a cofunction, right? Or it's a co-ratio. So I can introduce a 90 degrees and just reduce it in such a way that this one is the same as this. So I'll choose to reduce the 10 degrees, okay? So 1 over 2 and 1 over 2, obviously, it's going to go out. So I'll be left with sine of 90 degrees. 10 degrees, it's in the first quadrant. So I can say 90 degrees minus 10. So 90 degrees minus 10, or sorry, minus 80. It should give you a 10. So if I say 90 degrees minus 80 degrees, I should get a 10. And then we say it's all over. Underneath, I'm still left with cos of 80 degrees. Okay, let me just create a little bit of space. So from here, let's write this side. Okay, so 90 minus an angle, we said it's in the first quadrant. And in the first quadrant, sine is going to be positive, right? So it means you'll be left with positive cos of 80 degrees. Why are we making it to be cos all of a sudden while it was sine? Because we said 90 minus an angle. As soon as you see 90 minus an angle, then it means you've got a co-ratio or a co-function, and a co-function always changes the trig ratio. So if your trig ratio is sine, it needs to change to be cos. Then this is still all over your cos 80 degrees. And your cos 80 degrees and your cos 80 degrees, it's going to give you an answer of 1. Okay, so when you've got an angle which is above 360, don't be confused and be like, what am I going to do? What am I going to do? No, keep on reducing your angle until it becomes an acute angle. So what I did is that I said 360 minus 120. And again, I still reduced the 120 to your 60 degrees. So you keep on reducing it until you get what you're looking for. Okay? So that's your answer, positive 1. So I managed to put together a worksheet for you guys. So just make sure that you just go through this activity. You've got letter A up until letter L. So make sure that you just go through everything and you apply all the rules that I've taught you. Okay, and also worksheet number 2, whereby you are working with algebraic ratios. So you still need to go through all your the examples that I gave you, and then just do all of that work. Remember, with algebraic expression, algebraic ratios, you need to make sure that you draw your diagram first. So you can't do anything without a diagram. So with these ones, you need to make sure that you do have a diagram. And before I can end my lesson, I'm going to leave you with this. So before you get into an exam, or when you get into an exam, just take a piece of paper, or just at the back of your question paper, you must write all of this so that you don't forget as when you get to the trigonometry. So this is going to help you to answer all your questions in reduction formulas. So you say in the first quadrant you've got theta, right? And then you say 90 degrees minus theta. And then in this one you'll have 90 degrees plus theta. Then you'll get 180 degrees minus theta, right? And then here you've got 180 degrees plus theta. And in this quadrant you've got 360 degrees minus theta. Then you've got negative theta if you are going in an anti-clockwise direction. And then you've got negative 180 degrees plus theta. And then you've got negative 180 degrees minus your theta. And whenever you see your 360 plus theta, you must know that it's in the first quadrant. And whenever you see theta plus 360, you must know that again it's in your plus or minus, it's in your first quadrant. So don't be confused. Whenever you see all of that, it's in the first quadrant. So before you get into an exam, make sure that you write all of these things, or rather as you sit down for your exam, you write all of this so that whenever you are dealing with your stress or when you are confused with your maths, then you don't end up forgetting all of that reduction formulas. You get into an exam, you sit down, you write all of that down so that it can help you to answer your questions for your reduction formulas. Okay, so don't forget, again, you ask yourself, 90 minus theta is in which quadrant? First quadrant. If it's in the first quadrant, is it positive or the trig ratio is negative? If it's positive, it's positive. When it's negative, it's negative. That goes for all the other reduction formulas. Okay, thank you for joining my class today. I thank you.